what is green chemistry. And first of all, you have an enormous expert in green chemistry here at City University, Istvan Horvath, who's sitting in the front. But it is a cleaner way, it is trying to develop cleaner ways of making chemicals and materials. And the idea is to try and do something in the lab and transfer it into industry. And so it is very closely connected with what is in the UK, and I think here as well, called knowledge transfer. And when I started in green chemistry, one of the main areas was looking for greener solvents for doing chemical reactions. And this was really good from my point of view because I was working in the area of so-called supercritical fluids. And supercritical fluids are gases like carbon dioxide or ethene or steam that are compressed until they're nearly as dense as a liquid. Now, if you're not a chemist, it's still quite easy to understand that if you compress these gases, they are sufficiently compressed that you can dissolve solids. And the more you compress them, within reason, the more solid you can dissolve. And then if you release the pressure, whatever is dissolved comes out like a snowstorm or a rainstorm, depending whether it's a solid or a liquid. Now, you may not realize, but chemists are meant to make new molecules, new compounds, and I'm a very bad chemist in the sense I have always been hopeless at trying to make new compounds. So I would not do well in your discovery curriculum. And so when I started work in supercritical fluids, I saw real opportunity because I thought I could start making new compounds, or my group could. And we decided to try and make complexes of ethene or ethylene. And the problem with these complexes, with ethene coordinated to metals, is they decompose very easily when they're in solution. But if you're lucky enough to be able to make them in the solid, once they're in the solid, in the crystal structure, they're more stable. So I had the idea that you could mix a precursor compound, a starting material, with ethene, which is supercritical above 9 degrees centigrade. This is above room temperature, even in Nottingham. And the idea is you could pump it through a cell and shine UV light, which would cause a chemical reaction. And then you could use infrared light, infrared spectrometer here to see how the reaction was going. And you then have product dissolved with a huge excess of ethene. So if it came off, it would go on again. So the new compound is sitting there in solution, and then suddenly you release the pressure, and before it can decompose, it finds itself as a solid. At least that was the theory. And I was keen to do this because I had a German friend, Friedrich Gravels, who was a wonderful chemist, but couldn't isolate these compounds. So I wanted to show I was better than Friedrich, you see. And so this is the apparatus. Here is the pump. And the reactant dissolves up here, and the UV light shines there. And then there is the spectrometer, and the product comes out here. And I believe this is really how one should do chemistry, because literally you turn the handle, and out comes the product. And it worked. So you can see here is a chromium complex of ethene, this nice yellow compound. And I was really excited. We had done something that Friedrich couldn't. And it turned out that although this was a nice idea, you couldn't make very many compounds like this. And so it was just sort of my career as a synthetic chemist finished quite quickly. So then, shortly after this, there was an article in the journal New Scientist, magazine New Scientist. Have any of you read New Scientist? This is a popular science magazine in the UK, a bit like Scientific American, but it comes out every week. And there was an article about supercritical fluids in 1994 which mentioned my work. I was quite cross. I didn't think it was a very good article, didn't say enough about my work. It talked about other people's work as well. But it had an enormous effect on my career, because one of the people who read the article was this gentleman here, Thomas Swan, who at the time was the owner of the second largest privately owned chemical company in the UK, which is also called Thomas Swan. And it was a place called Consett in the northeast of England, which most people, even in England, have never been there. And it is famous mostly because they make expensive potato crisps in the town. And they also have the chemical company. And he was interested in hydrogenation reactions, adding